All right, so now we're going to state and check the assumptions for the hypothesis test. Now, every hypothesis test has some assumptions that must be met to make sure that the results of the hypothesis test are valid. Those assumptions are different for each test, and they will be on your cheat sheet for the exam, so you do not need to memorize what those assumptions are. Okay, so all of our hypothesis tests are going to have this first assumption that we took a random sample. Again, we want a representative sample from the population. So the first condition here is that a random sample of size n was taken, and this was given. So, all right, so they said they took a random sample of 30 of these batteries. And then the population standard deviation has to be known to be able to use the normal distribution here for quantitative data. And so again, they told us that way back at the very beginning of this problem, they told us sigma was 25 days, so the value of sigma is known. And then the sample size has to be at least 30, or the population of the random variable is normally distributed. So in this case, again, this is an or statement, so just at least one of those has to be true. And so in this case, you know, we need n to be at least 30, and they did take 30 batteries. So 30 is greater than or equal to 30, so all of these conditions are met. So again, these conditions should sound familiar because we saw these exact same conditions in section 6.5 when we were dealing with the central limit theorem for the mean. All right, so in this case, the name of the test that we're going to use is called the one sample z-test. We're going to find in the later chapters that we're really never going to perform this particular test on quantitative data again, because it does require that sigma has to be known, which it usually is not. Almost rarely ever is sigma known. And so we're going to get a different type of test in one of the later sections for that. All right, step 5. So the fifth letter in phantoms is T, so we need to look at a test statistic. Again, the test statistic is going to depend on the type of data that were collected, how many samples of data, what parameter you're testing, and assumptions that need to be checked. So in this case, lifetime is quantitative. And we took just one sample of 30 batteries, and we are testing the mean. So the assumptions were checked above to use the one sample z-test. So a z-test uses a z-score. Okay, and again, the cheat sheet for this unit will help you pick this. Like, all of that information would be on there. Okay, so our sample statistic here, since it's a hypothesis test for the mean, the sample mean would be x bar, which we computed earlier and got 490 days. Okay. Our test statistic here for a z-test is going to be the z-score. Again, you do not need to memorize these formulas. They are on the formula sheet. And we plugged these values in earlier, so we got 490 minus 500, and we divided by 25 over the square root of 30. And so that came out roughly negative 2.19. So then the O in phantoms is to obtain the p-value, or that tail probability. So again, if we look at the picture that we had earlier, so we can see exactly the shaded area that we're computing here. So again, in this case, we computed the probability of getting an x bar less than or equal to 490. And again, given mu is 500. And so again, we use normal CDF for that. Okay, from our shading here, we can see that it starts on the left at negative infinity, ends at 490. The mean was 500, and the standard deviation was 25 over root 30. And if we compute that, we get 0.0142. Okay, and so that is our p-value that we get here. So that's the area here in this left tail. So again, this test is called a left-tailed test, since the p-value represents the area in that shaded left tail.